The exit plan of astronomers has found that using our new 10 billion toy, it will be years before that project becomes a reality, if it goes as planned. The journey to Proxima B will take about 20 years, so realistically, it will be several decades before we can confirm if there is indeed life on that planet. The age-old question of whether we are truly alone in this universe persists. The James Webb Telescope has discovered some terrifyingly human-esque things far, far away from Earth that lead us closer to the answer. Our search for life outside of us has been rampant throughout each human civilization, so much so that we have thousands and thousands of media, literature, and theories on this subject. Our wonder regarding our place and loneliness in the universe has been constant, as if it is ingrained inside of us to always search for a companion, no matter how alien-like. We might be getting closer and closer to the answers we truly want, but are they truly the answers we are looking for, or are they much more terrifying? Join us as we explore the latest discovery in the realms of galaxies and planets on the quest to find something we might not be prepared to witness. Lights far, far away, scientists have discovered what could be the most groundbreaking discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting hypothetical question was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet, such as Proxima B, the closest exoplanet to Earth. Proxima B, about 4.25 light-years away, was believed to be tidally locked, with a permanent day side and night side, similar to our Moon. A hypothetical technological civilization on Proxima B might transfer heat and electricity from the day side to the night side using photovoltaic cells that generate electricity from starlight. Subsequently, in a paper with Manusvi Lingam as one of the researchers, it was shown that significant coverage of the day side by solar panels could be detected with future telescopes. Since JWST was more advanced, it would allow us to extend our search for artificial lights to habitable exoplanets like Proxima B. Now, in 2024, it is possible that the James Webb Space Telescope did just that. Using its higher sensitivity and greater range of capabilities, the JWST might have discovered the lights we were looking for and possibly hurled us into another big surge of human evolution. But first, let us dive into the world of planets and exoplanets to learn how all this was even possible. James Webb's mission explores Proxima Centauri B's secrets. Throughout history, humans have wondered about the nature of the universe, what we are, where we come from, and where we go. These are common yet extremely difficult questions that mankind has tried to answer as soon as he gained consciousness. Now, in the age of exponential technological advancement, one wonders if we are any closer to answering these questions. If you were to ask a philosopher, he might say we are still at level 0 of understanding ourselves in the universe. However, ask an astronomer the same thing and watch him jump up and down in excitement as he rushes to tell you the latest discovery humans have made about the universe using their nifty tools. These tools, although not paid much attention to by the average public, are quite literally a manifestation of human evolution itself. We now have the world at our fingertips, and it is time we move forward and get the universe at our fingertips as well. One such way to do that has been deduced by scientists and astronomers through the technology we harness. A specific creation of that technology is now responsible for the recent discovery of what might be light on a different planet, light-years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the legacies of human expeditions into space to answer some ever-present questions. Are we alone? Who's out there? Where do we begin, and where do we end? This infrared astronomy tool has already begun answering these questions, although partially. First, you might find yourself asking what Proxima B is. Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri CB. It is a super-Earth exoplanet and orbits an M-type star. Super-Earth exoplanets might confuse you, but do not worry, as this text will quell all your burning questions. Super-Earths are a class of planets that are more massive than Earth yet lighter than ice giants like Neptune and Uranus. They are truly one of a kind. They can be made up of gas, rock, or even a combination of both, and their sizes can vary from twice the size of Earth to 10 times its mass. They really put the super in Super-Earth. As for Proxima B, it is a super-Earth and an exoplanet, meaning that it is a planet that traverses outside the solar system. The very first possible evidence of an exoplanet was found in 1917, although it managed to stir up little curiosity and recognition. However, in 1992, the first confirmed detection occurred, which left scientists speechless. Another exoplanet, first detected in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of these, 896 systems have more than one planet. These marvelous discoveries are orbiting an M-type star. To explain the M-type star, you need to understand the red dwarf. A red dwarf is the smallest kind of star in the main sequence, hence the name. In the neighboring regions of the Sun, red dwarfs are by far the most common type of star to be found in the Milky Way. They have very low luminosity, and since luminosity is one of our main tools for planet detection and other types of deductions, red dwarfs are not that easy to observe. The sneaky stars have variable definitions and names depending on their temperatures and sizes. For example, M-dwarfs, or M-type main sequence stars, yield a maximum temperature of 3000 K, hence getting their name and attributes. Coming back to Proxima B, its mass is known to be equivalent to 1.07 Earths. Interestingly, it only takes 11.2 days to complete one orbit of its star, compared to our 365.25 days. You can estimate the size of the star Proxima B is orbiting. Staggeringly, under the measurement of the entire electromagnetic spectrum, the star has a total luminosity of only about 1.6% that of the Sun. Additionally, in the visible light spectrum, its luminosity seems to dull even more as it appears fainter. It only illuminates 5 to 6% of the Sun's luminosity in the visible light spectrum, emitting a significantly lesser amount of light energy compared to the Sun. Over 85% of its emitted energy is in the form of infrared radiation. Orbiting about 0.045 to 0.056 Australian dollars away from its star, Proxima B's discovery was announced way back in 2016. You might be wondering why Proxima B, with millions of stars, planets, and galaxies, is so fixated on this particular celestial body. Well, there are a few reasons that contribute to the keen interest astronomers have in this place. First and foremost, Proxima B is the closest known star to our Sun, and by definition, although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a mere blip. Hence why Proxima B, our closest known star, is high up on the priority list at the moment. It is also a part of the triple star system called Alpha Centauri, and although Proxima's luminosity is very low, the system itself appears as one of the brightest constellations in the night sky, only behind two others called Sirius and Canopus. However, the most interesting thing about Proxima Centauri B is that it might potentially be habitable. Since it falls under the habitable zone, the possibilities surrounding the star are endless, and thus astronomers have taken on the expedition to explore the depths and limits of the potential of the star. That is where the James Webb Space Telescope comes in. The four key goals of the JWST are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, understand star and planet formation, and study planetary systems and the origins of life. As the JWST continues its exploration of the said exoplanet, we get closer and closer to the completion of these missions, from searching for exoplanets to searching for alien life. So what exactly is SETI, one might ask? Considering that humans have always been a curious species, poking and prodding into literally anything and everything that moves and doesn't move, it makes sense that a quest like SETI came into existence on such a large scale. Imagine that God has organized a grand cosmic treasure hunt, but with a twist. Instead of gold, we are tasked with being on the lookout for signals, more specifically electromagnetic whispers, from civilizations beyond our wildest dreams. SETI, short for the search for extraterrestrial intelligence, is like the world's most high-stakes game of hide-and-seek, with our planet as the seeker and the vast universe as the seemingly infinite hiding spot. It is one of those fields where scientists are modern-day Sherlocks, tuned into radio waves and scouring for that elusive, we are not alone moment. This game of cosmic eavesdropping began in earnest in the 1960s. Frank Drake, a visionary astronomer with a penchant for thinking outside the earthly box, pointed a radio telescope at two nearby stars and listened, hoping to hear something that might resemble an alien hello. Although the stars remained silent, the attempt sparked a movement, setting the stage for what has now become a decades-long search for extraterrestrial life. But let's not be mistaken, SETI is not just about listening, it's about sending messages too. In 1974, a group of scientists beamed a message into space via the Arecibo telescope. This message, designed by the likes of Carl Sagan, was like a cosmic postcard sent out to anyone who might be listening. We included things like DNA's double helix structure, a human figure, and a rough sketch of our solar system. This attempt was a long shot, aimed at a star cluster some 25,000 light-years away, and yet, it was a profound statement of intent. It was humanity's way of saying, we are here, we are curious, and we would like to chat. Now, before you go thinking that SETI is all about those grainy UFO videos that flood the internet, let me clarify. This is serious science. The researchers involved are meticulously sifting through data, looking for anomalies in the cosmic background noise, anomalies that could be anything from a distant planet's magnetic field to a deliberate signal from another civilization. The work is painstaking, and the chances of success are slim, but the stakes are high. What if we do hear something, or what if the JWST's recent light findings are the first step in hearing that, hello? What if that something is a message, not just noise? How do we respond? And more importantly, are we ready? The answers to these questions are not straightforward. The consequences of finding extraterrestrial life could be as mundane as confirming we are not alone or as earth-shattering as forcing us to rethink our place in the universe. It is this potential for discovery that drives the search, keeping SETI scientists listening, watching, and waiting. In the end, SETI is not just about finding aliens, it's about understanding ourselves. We look to the stars not just out of curiosity but because we are explorers at heart. And while the search has yet to yield that definitive eureka moment, it continues, fueled by a deep-seated belief that somewhere out there, in the vast expanse of space, we might find a kindred spirit, or at the very least, an answer to the question that has haunted humanity for millennia: are we truly alone in the universe? The search for extraterrestrial intelligence is not merely a scientific endeavor, it is a quest that touches the very core of what it means to be human. We are seekers of knowledge, explorers of the unknown, and dreamers of possibilities. The quest to find something or someone beyond our planet is not just about expanding our understanding of the universe, it's about expanding our understanding of ourselves. The universe is vast and ancient, and the possibility that we are not alone is one that has intrigued and inspired humanity for centuries. SETI is a testament to our enduring curiosity and our desire to connect with the cosmos. Whether or not we ever find extraterrestrial intelligence, the search itself is a reminder that we are part of something much larger than ourselves. We are, after all, inhabitants of a tiny blue planet, orbiting a star among billions, in a galaxy among trillions. Our place in the universe may be small, but our potential for discovery is limitless. The James Webb Space Telescope, with its ability to peer deeper into the cosmos than ever before, is a powerful tool in this search. Its discovery of possible artificial lights on Proxima B is a tantalizing hint that we may be closer than ever to finding an answer to the question that has driven us for so long. But even as we search, we must remember that the search itself is a journey that has the power to transform us, to deepen our understanding of the universe, and to connect us with something greater than ourselves. So as we look to the stars and listen for signals from distant worlds, we are not just searching for aliens, we are searching for our place in the cosmos. We are searching for a connection to something beyond ourselves, something that can remind us of our shared humanity and our shared destiny in the universe. In the end, whether or not we find extraterrestrial intelligence, the search will have been worth it. Because the search for life beyond Earth is also a search for meaning, a search for purpose, and a search for a deeper understanding of who we are and what it means to be human. As we continue this search, let us be guided by our curiosity, our sense of wonder, and our hope that, somewhere out there, we may find a connection that will change us forever.